Hello, my name is Christopher Shulby, and I'm going to be talking about my project, iPrompter, an intelligent speech tutoring system for native Brazilian learners of English. The idea of the project is that it will give the learner intelligent feedback. What that means is based on the pedagogical motivations that the learner will learn metacognition, learn how to learn. And that means that when the learner makes a mistake, first we have the whole problem of actually identifying the errors and all of that. But then beyond that, in the speech recognition part, we also have to give the learner good feedback, and also based on the learner's level and their aims as far as learning English. So for instance, if I have a learner that's fairly novice and would like to learn how to converse better, to give a basic presentation, something like that, then I'm going to be looking more for errors that actually impede intelligibility. So that's great. Motivation, I don't really have to go over this a whole lot because most of you who are seeing this know that Brazil is really bad at English. And not just really bad, but they're really bad even in the Latin American context. And being the great economy that Brazil is, it should be a lot better compared to other Latin American countries. So basically, as far as foreign language accent is concerned, just bringing a little bit of theory here, is that first impressions impact the past, present, and future alliances. This is really important because when we start giving an academic presentation, which is the focus of iPrompter, since we're talking about university students who want to better their English in an academic context, someone goes to a conference and they're going to present their thesis work or a paper that they've worked very hard on, but their English skills are not that great because here in Brazil, they speak mainly Portuguese. They read a lot of English, but they speak mainly Portuguese. And so they're not used to speaking a lot of English. When they get there, deer in the headlights, they get scared, and they start speaking maybe even worse than they normally would because they get nervous. I'm going to give a couple examples here from Brazilian Portuguese speakers when they speak in English. We have the famous th versus f. A sound that doesn't exist in Portuguese that's often mistaken. So think becomes think. That's really not too bad as far as intelligibility is concerned. Most people understand it, but obviously they perceive the accent and you might get a few giggles. Another one that I'm going to talk about that really does impede intelligibility is the epenthesis of the I in Portuguese. We have a small little vowel that tends to creep in at the end of words that end in stops. That's a technical term for certain classes of sounds that have an abrupt stop at the end. So, for instance, think can even be thinky, or even worse, most likely, finky. And for a native speaker of English, how think becomes finky becomes very difficult to understand, and often they don't understand at all. So basically, that's my gap. I'm not going to go a whole lot more into that. But here are my research questions, which basically, with speech recognition, I want to close that gap. The fact is there aren't a lot of corpora available for non-native speech, and definitely not for Brazilian Portuguese native speakers. So that's the first thing that we have to address, and definitely the most difficult part of this project. And then beyond that, how artificial learning techniques and knowledge and things can help us learn from the errors effectively. All right, so basically we want to be able to simulate the intelligence of a human tutor, the perception of a human tutor, and being able to perceive the errors and give good feedback. I'm going to skip maybe just a little bit of this with the language acquisition stuff, just to compare it to some of the non-native speech corpora that we have available. You can see that there is very, very little available. Most of them are around just a few hours, or at best 24, as in this case. But Most of them are very, very focused on a specific task. And the Kobai corpus, which is the only other one that actually has Brazilian Portuguese speakers speaking in English, the only known corpus, it has 12 and a half hours, but only 60% of it is transcribed. The speech is very spontaneous, and it's not transcribed in a way that would be useful for speech recognition systems. As far as the speech corpus is concerned, my corpus is recorded in a study type environment with laptops and PC microphones. It's phonetically balanced with a manual narrow transcription. It was collected from Wikipedia. It has 32 million sentences. It contains phonetic, syllabic, stress, and POS information, which most speech corpora do not. They only have, at best, phonemes and usually just the orthographic transcription. And the current corpus is at about 18 hours. And if we look at that compared to the other corpora that are available, we can see that there are only, I believe, just one corpus that's actually larger. The ERJ corpus, I know, is just their single sentences, and they have pronunciation scores, but it won't give us 18 hours. And I obviously plan to collect quite a bit more, so that's good too. Pronunciation model that I'm creating, it has a native model for reference and an auto-native model with standard and non-standard variations. This was created using a rule-based algorithm from our knowledge of Brazilian Portuguese and their use of English and some of the disfluencies that can occur. The acoustic model, in this case, would be the first of its kind for Brazilian speakers. It's trained with natives of Brazilian Portuguese and General American English. The models are currently trained with a HMM-CNN architecture employing a knowledge-driven hierarchy. And I am just going to move a little bit here just to show that the prompt and the recording obviously is not always the same. And this requires not only the force alignment and revision of that, but sometimes quite a bit of manual work to make sure that we get it right. The labels are created using force alignment and HMM. The acoustic labeler was built with a small amount of hand-labeled data, about 6 hours of audio that I created. The features are extracted with a CNN with a sliding Han window of 25 milliseconds and a 10 millisecond step. I'm not going to go into what a CNN is, or not even too much into the architecture of that, but I do want to get a little bit to the hierarchical questions that I have here, which is whether it is speech or non-speech, a sonant or an obstruent, depth, manner, and place. I use this to divide the classes a little bit so that the SVM is able to focus on smaller problems instead of one big problem, and that helps in the classification. So in conclusion, the idea is to create an intelligent speech tutor, which is capable of helping Brazilian learners learn English and help facilitate that learning using metacognition, and to close the gap on non-native speech, which has not really been well attended to even since deep learning has entered in speech process. That is about it. If you would like to contribute, this is the bare IP for my corpus. 30-40 minutes of your time would be a huge help. And now I'm going to talk about miojo, because I think I might still have some minutes. You must first boil the water. Put the pasta in the boiling water. You have to wait about 3 minutes. Then you open the seasoning package. It's good to use scissors because sometimes they don't open. It can get really hard to open them with your hands. And after 3 minutes, you take out the noodles and you mix it with the seasoning package, and you have a meal and you're ready. Enjoy.